Yeah, hi, hello. Greetings for the day. This is Sai Harshit Kovuri from CS513 course, Topics of Operating Systems. Currently, I am going to present you the video and PowerPoint presentation of the research paper, A Domain and Type Enforcement Unix Prototype, which was published by Fifth Unix Security Symphorium, Salt Lake City, which, which was held at Utah on June 1995. These are done by the people like Lee Badger, Daniel F. Sterling, David L. Sherman, Kenneth M. Walker, and Sheila A. Hagiath. Now, I'm gonna give a rough introduction regarding this. And the thing was like, what is this? What is the domain and type enforcement Unix prototype? Domain and type enforcement is a security architecture designed to provide fine-grained access control and strong separation of domains with an Unix-like operating system. The concept of DTE originated in the early 1990s, developed to offer more flexible and comprehensive approach to access control compared to traditional Unix disaggregation access control, that is DAC mechanisms. And some core concepts of DTE, like first one is domains. And what are these domains? A domain in DTE represents a security context or environment within which processes execute. Domain define the principal operations and interactions for the processes. Each processes runs within a specific domain which dictates its access to resources such as files, devices, and other processes. There are some particular types in this that are like types are used to label system resources such as files, directories, and devices. Each resource types has an associated set of access rules that specify which domains can access resources and with manners like read, write and execute and etc. Now we'll be going to the slide one, that is the weaknesses of traditional Unix security. Reliance on root user and careful administration. What's the thing was traditional Unix securities relies heavily on single root users account with complete system access. This concentrates a lot of power and responsibility on one account, making it a prime target for what attacking attackers like cyber attacks and all those things, and increasing the risk of additional misuse. There are some type enforcement rules also in this. These rules defines the relationship between domains and types, specifically with actions a domain can perform on resources of a particular types. The rules are centrally managed and typically defined in a policy files which is consulted by the operating system's security module to enforce access control decisions. And the thing was, increasing network connectivity raises security concerns as Unix systems becomes more interconnected through networks. The potential attack surface expands. A vulnerability in one system can be exploited to gain access to others. The weakness of traditional Unix security, it's the second slide. Here, the weakest link phenomenon. The thing was a compromises of a privileged program with root accesses can exploit the entire system. If an attacker gains control of program like web server or mail server, they can potentially use what they can use to potentially use it launch further attack or steal sensitive data. And difficulty in implementing, coordinating security policies, enforcing consistent security policies across various applications and data types can be challenging with traditional mechanisms. It can be difficult to ensure that all users and programmers have the appropriate access privileges. And this thing was implementing here. The first thing we will be doing is implementing in Unix. How we'll be implementing in the Unix? In a Unix prototype of DTE, the system would implement the following components. Like what the things is, first one is policy definition and management. A policy file that defines domains, types, and type enforcement rules, and tools for administrators to create, modify, and manage these policies. And the second thing was kernel modifications. Modifications to the Unix kernel to ensure the DTE policy. This involves adding hooks to system calls to check type enforcement rules before allowing access to resources. And the third thing was labeling mechanism. A mechanism to label processes and resources with their respective domains and type. This could be done at the time of resource creation or dynamically during system operation. Domain transaction mechanism. Here the support for domain transition where processes can change their domains under control conditions. This allows for flexible execution environments while maintaining strict access controls. Here we'll be searching and doing some domain and type enforcement, a new approach that we've been doing the approaches of this. Access control mechanisms. DTE is a security mechanism designed to control access resources within a Unix system, partitioning the operating systems into domains. DTE divides the operating systems into distinct security domains. Each domain acts as a secure compartment where process operates with limited privileges and enforces access control policies based on domains and object types. DTE enforces access control policies that dictate how process in one domain can interact with objects like files, devices, etc. of different types like confidential and public. Here are some of the understandings, the building blocks of the DTE. And the details are domains. Define secure compartments with the systems. Process running with a domain inherits the access privileges of that domain, and example domains like user domain, web server domain, and database domain. And some types is like uh, classify objects like file devices based on their sensitivity of purpose. Define the level of access required to interact with the object. And here are some examples are confidential file, log file, public document. And understanding the building blocks of the DT, it's the second slide. Policies specify permitted interactions between domains and types. Define what actions like read, write, execute processes in a domain can perform on objects of different types. For example, policies use domain can read log files but cannot write the confidential files. Now I'm going to give you the advantages of domain and type enforcement of the first, and this is the first part. Like improved security postures. Here the posture means the particular line or the particular way, it's the posture it'll be using like it gives an important and secure posture, like by compromising the system and restricting access based on domains and types. DTE can significantly improve the overall security posture even if a program is compromised. Its ability to harm other parts of the system is limited. Enforces security policies. DTE enforces consistent security policies across the entire system. This reduces the risk of human error or oversight in managing access control and ensure that all users and programs have the appropriate privileges. And another important advantages is its fine-grained access control. Like DTE provides more granular control over access permissions compared to the traditional Unix DAC, and it can prevent unauthorized access by strictly enforcing the predefined security policies. And things was like improved security by enforcing strong separation between domain. DTE reduces the risk of privilege escalation and limits the impact of compromised processes. It helps in containing security breaches and mitigating potential damages. And the advantages on type and another some more advantages I'll be including, like increased manageability. That is like DTE simplifies security administration by providing a centralized framework for defining and enforcing security policies. Administrators can manage access control at a more granular level, making it easier to maintain a secure system. Potential compatibility with existing systems. The DTE design aim for minimal duration to existing Unix systems ideally. DTE could be implemented without required major modifications to the underlying operating system architecture. And some more flexibilities like DTE policies can be tailored to specific security requirements, allowing for customized and adaptive security configures. These flexibilities make DTE suitable for wide range of applications and environments. Extending DTE for network security. Control access to network resources. DTE can be extended to control access to network resources such as shared files and remote systems. This can be help prevent unauthorized access and data breaches across a network of interconnected Unix machines. Interactions with network file systems, that is NFS security. NFS means network file system. DTE can potentially integrate with existing security mechanisms like NFS, network file systems, to further enhance network security by leveraging existing protocols. DTE could enforce access control policies on shared resource access over the network. And for example, scenarios, consider a web server running on a Unix systems with DTE implemented. The web server process runs in a specific domain. For example, web underscore domain. Files and directories related to the web servers are labeled with types such as web content type and web config type. And the DTE policy defines that web domains can read web content type but cannot write to it, and can read and write. Web config type only duration initialization. Other domains such as user domains or system administration domains have different access permissions to ensure that only authorized processes can modify web server configures. By enforcing these policies, right, we'll be doing in this another slide of this. Potential for security communication channels between domains. DTE concepts of domains could be extended to create secure communication channels between domains on different systems. This could help ensure that only authorized data is exchanged between trusted domains, like only the data can be transferred from one trusted domain to another domain. As you understand it, right? The thing was the enforcement of these policies did ensure that even if the web server process is compromised, the attacker's ability to modify system files and access sensitive data is significantly very limited. And we'll be notes looking on the challenges like accessing the DTE prototype, successes and challenges. Prototype successfully enforced after enforced access control policies. The evaluation confirmed that the DTE prototype effectively enforced the security policies defined with the system. This demonstrated DTE's potential to improve access control and prevent unauthorized actions. That means like unauthorized person cannot access to this. And some are like policy complexity. Design and maintaining a comprehensive DTE policy can be a complex and requires careful planning. Incorrect policies can lead to the overall restrictive or comprehensive access controls. Next is demonstrated potentials for improved security. By successfully enforcing access control policies, the prototype provided evidence that the DTE could lead to an overall more secure Unix system. By restricting access based on domains and types, DTE can help mitigate the risk associated with the compromised programs or human errors. And another thing was like uh, areas of improvement. Like in performance overhead, the prototype introduced some performance overhead compared to the traditional Unix systems. This means that the system might run slightly slower due to the additional process required to DTE access control checks. Complexity of policy management. Managing complex security policies within the DTE framework could be challenging for system administrators. Defining a large number of domains, types, and access rules can become iterative. And performance overhead. The additional checks imposed by DTE can introduce performance overhead. Efficient implementation and optimizations are necessary to minimize the impact on system performance and usabilities. Administrators and users need to be trained to understand and work with DTE policies. User-friendly tools and integrated are essentials for manage DTE effectively. The road ahead of evolving DTE for tomorrow's security needs. Uh, Optimizing performance to minimize overhead. As identified in the evaluation, the DTE prototype introduced some performance overhead. Further developed should focus on optimizing the framework to reduce the impact on system performance. This could involve exploring more efficient algorithms for access control checks or leveraging hardware assisted. Developing user-friendly tools for policy management. Managing complex security policies within DTE can be challenging. Further efforts should involve developing and users to simplify the process domain types access control. This could include graphical interfaces, policy wizards, or integration with the existing security management tools. And here, the DTE offers a novel approach to access controls in Unix systems. Like recap, the DTE presents a new way to manage access control within a Unix system. It leverages the concept of domain and object type to create a more compartmentalized and secure environment. Prototype demonstrates potential for improvement securities and policy enforcement. The prototype successfully demonstrated TTE's potential to enforce access control policies and improve overall system security by limiting unauthorized access and mitigating risks. Further research and development can refine DTE for broader adoption. While there are areas of improvement in performance and policy management, continued research and development can address these challenges and make DTE a more practical and widely adopted security solution for Unix systems. And hereby, I conclude that in a summary, a domain and type enforcement Unix prototype offers a robust framework for enhancing security through fine-grained access control. While it presents some challenges, it benefits in terms of improved security and flexibility, which make it a valuable approach for a securing Unix-like operating system. Thank you. I thank Professor Gardner for giving me this wonderful opportunity, and thank you so much.